so here we are with section 12.5 today. So we're going to talk about reflections and symmetry. All right, so our goal is to reflect figures and then identify lines of symmetry. So first we need to know what a reflection is mathematically speaking. So a reflection is flipping an object over a fixed axis, or over, let's just say, a line for now, okay? So flipping an object over a line, that's reflection. So then the line of reflection is the line that you flip over, okay? So then line of symmetry is the line that if an object were reflected over would line up with itself. I know, I ran out of room a little bit. Okay, so the line that if an object were reflected over would line up with itself, and you'll see what I'm talking about as we get into the symmetry a little later. Oh, shoot, I mixed these two up. I'm sorry. So that's line of symmetry. Line symmetry is if an object, could match up with itself when folded over. All right, some really common examples of line symmetry. Think of a butterfly, right? When you're in elementary school and you put the paint on the one side of your butterfly and then you folded the construction paper and you got a beautiful butterfly on both sides, that's line symmetry, okay? But first, we're going to start with some reflections. So example 1, tell whether the transformation is a reflection. If so, identify the line of reflection. So if I took this arrow here and I reflected it over this line here, would it go here, is the question. Well, hopefully we can all see that it's yes. And then it says identify the line of reflection. Well, the line of reflection in this case happens to be the x-axis. That's what you're folding it over. All right, now letter B here. If I take this shape, is there any way that I could flip it so that it lines up here? Hopefully you said no, right? It's actually, if you're curious, this is a translation that you learned about yesterday. This is a translation, not a reflection. Okay, let's look at C. Could I take this object, or this triangle, and reflect it in some way to get to this triangle? The answer is yes. And that line that we're reflecting it over is the y-axis. Okay? Hopefully that's pretty easy for you guys to see. If not, make sure you're asking Miss B, and maybe she can help explain it a little better, or Mr. Torres, or Mrs. Schmidt, or me on Thursday. It's up to you. You have options. Okay, now we do have coordinate notation for this as well, but there are actually two specific rules. So if we're reflecting over the x-axis, then our rule is that xy is going to go to x comma negative y. Because if we reflect from here to here, all that's changing is this y number, right? Because we're counting 1 and then we count 1 again, right? We count 1, 2, 3, and then we count 1, 2, 3 again. So we're just changing this y value. If it's positive, it goes negative. If it's negative, it goes positive. Okay? The second rule we have is reflection in the y-axis. And that rule is going to be xy goes to negative x comma y. And again, if we're reflecting over the x-axis, all that's changing is that x, right? I'm moving side to side. I'm not moving up or down any. So 1, 2, 3, 4, right? All I'm changing is that x-axis. If it's positive, it goes to negative. If it's negative, it goes to positive. Okay? So make sure you have these two rules written down. They're super important. Star them, box them, make them stand out in your notes because you're going to want to be able to locate them. Okay, so let's try one. Example 2. Draw triangle ABC with these vertices. So A is at 2, 2. That's A. B is at 2, 5. Way up there. C is at 4, 1. Okay, so there's my triangle. It's kind of a weird looking triangle, but it's a triangle. Okay, then find the coordinates of the vertices of the image after a reflection in the x-axis and draw the image. So if I'm reflecting in the x-axis, right away you should look up your rule and you should say xy goes to, and if I'm going over the x-axis, my y is what changes, so x negative y. So that tells me that I multiply the y coordinate of each vertex by a negative 1. So xy goes to x negative y. So all that I'm doing is I'm taking this y coordinate and multiplying it by negative 1. So A prime would be at 2, negative 2. B prime will be at 2, negative 5. C prime will be at 4, negative 1. Right? Notice the x values didn't change at all. All that is changing is the y values if you're reflecting over the x-axis. It's like the opposite letters. So then I graph the new points. So A prime is at 2, negative 2. A prime. B prime would be at 2, negative 5. And C prime is going to be at 4, negative 1. So there is my new triangle, or my image in this case. Right? And if you looked, right, if you folded your paper over the x-axis, you can go ahead and try it. If you fold your paper over the x-axis, it should line up perfectly. That is what a reflection is. All right, so let's go ahead and try the checkpoint here. Again, just like yesterday's video, it's going to pause, and I want you to enter your new image coordinates over on the right-hand side, and then we will go from there, and you can check your graphs in the video. All right, so if I am reflecting over the y-axis, then my x value is what changes. I have AB going to, oh, I'm sorry, I got the wrong class in my brain all of a sudden. All right, so we have xy, that should be a parentheses. Xy goes to negative x comma y. So my x value is what I'm multiplying by negative 1. So this is changing, that's changing, that's changing. So A prime would be at 4, negative 3. B prime would be at negative 4, 4. Oh, I'm sorry, positive 4, 4. And C prime would be at positive 1, negative 3. So then I plot my original. So A is at negative 4, negative 3. That's my original A. B is at negative 4, positive 4. That's my original B. C is at negative 1, negative 3. That's my original C. So I graph that triangle there. Then I'm going to reflect over the y-axis. So let's see if I did my math right. A prime is at 4, negative 3. That's A prime. B prime is at 4, 4. C prime is at 1, negative 3. So if I did this right and I connect these dots, this, right, and you could fold your paper over that y-axis and it should line up perfectly. All right. Again, if something doesn't make sense or you just don't know why you went wrong, feel free to ask Ms. B, Mr. Torres, Mrs. Schmidt, or myself, depending on what day it is. All right. Last but not least, we have this concept of symmetry, lines of symmetry. Right, so draw the lines of symmetry on the figure. Tell how many lines of symmetry the figure has. So in other words, drawing how many lines down the center of this would it line up with itself? Right, well the heart, I'm going to skip the lightning bolt for a second. The heart's pretty simple, right down the middle. Right, there's no other place that I could cut it that would line up perfectly, so it only has one line. Okay, this no smoking sign or whatever you want to call it, don't enter sign, I could draw one right down the middle here, right? But I could also draw one going the other way. I know my line's not quite straight, it kind of curves a little bit, but right, I could draw one that goes through the middle there. And really that's it. So this one has 2 lines of symmetry. Okay, going back to the lightning bolt. Is there any way that I could fold this lightning bolt so it would line up with itself? Well, if I drew one right through the tip, right, this is probably what a lot of you were thinking, like right down the middle there. The issue is that this area would land in this white space. It doesn't line up, so this one actually has 0 lines of symmetry, right? But that's really all this is, lines of symmetry. It's just looking at the picture, seeing where you could where you could cut it or where you could fold it so that it would line up with itself again. Okay? So you guys go ahead and try checkpoints 2, 3, and 4. Go ahead and enter your answers over on the right-hand side, and then hit continue to see how you did. All right, so on number 2, since these are marked the same, I could definitely draw one this way, and I could draw one this way, and because it's slanted, that's it. I can only draw 2. Okay? All right, let's look at the next one. Number 3, the rectangle. Well, I could draw one this way, I could draw one this way, and you might think you could draw one in here, but I'm going to tell you right now, you cannot fold a rectangle on the diagonal for it to line up with itself. If you think you can prove me wrong, go ahead and try it with a 8.5 by 11 piece of paper, and it will not line up perfectly. So that dotted line is not valid. So again, you can only have 2. Now over here, we have what we call a regular pentagon. Regular because all these angles are marked equal, and all these sides are marked equal. So it's called regular. Now with any regular shape, so like a square would also count, any regular shape is going to have more lines. Because I can draw one through each vertex. So there, and there, and there, and there, which is 5 lines. Oops, I missed one. And there. So that's 5 lines of symmetry. Right? There's nowhere else to cut it because I cut it everywhere. So in a regular polygon, the number of lines of symmetry will be equal to the number of sides of the regular polygon. But it has to be regular. All the angles and all the sides have to be marked equal, otherwise you cannot assume that it's regular, right? Just like our rectangle and our parallelogram in 3 and 2 weren't regular, so they had less lines. All right, hopefully that makes sense. If not, make sure you're asking questions. Otherwise, that does conclude section 12.5, and have a great rest of your day.